Hi guys, so today what we're going to look at is the special trig ratios of 30, 45 and 60 degrees. So the first thing I'm going to do is I'm going to draw a equilateral triangle of length 2. So 2, 2 and 2. I have to excuse the triangle, it's not that good. 2 and 2. And what I'm going to do is I'm going to drop a perpendicular from the top of the triangle down to the base, as so. And I'm going to get a right angled triangle. And I'm just going to take one of those triangles out. So I'm going to take the left one out, and what we can see here is I now have a 90-degree angle just there. But this length now, it's bisected the bottom line here, or the base. So this now is 1, and this is of length 2. Now that means that this angle here has also been bisected, and this is 30 degrees, and this is still 60 degrees from the triangle here. Now that allows us to calculate this length on the right hand side here by using Pythagoras, because we know that it's a right angle triangle. So Pythagoras states that the square of the two shorter sides, the sum of the square of the two shorter sides is equal to the square of the hypotenuse. So what we have here, we're just going to call this h. We have 1 squared plus h squared must equal the hypotenuse squared, which is 2 squared. That means we get 1 plus h squared is equal to 4. H squared is equal to 3. So the 1 take away 4 take away 1 is 3. And therefore h is equal to root 3. So that now means that this length here is root 3. Now I have all the lengths of the triangle, I can start working out the trigonometric ratios. We already know that the trig ratios are as follows. So I know that sine of theta, where theta is the angle, is equal to the opposite over the hypotenuse. Cos of theta is equal to the adjacent over the hypotenuse. And tan of theta is equal to the opposite over the adjacent. So I'm just going to redraw the triangle. So there it is. And I'm going to use the 30-degree angle just here. We know that this is side 2. We know this is of length root 3. And we know this is length 1. So what I'm going to do now is I'm going to label all the sides so I don't get confused. So this is my hypotenuse because it's opposite the right angle here. This is my opposite because it's opposite the angle that I have. And this is my adjacent because it's the only one left. So I'm now going to work out, using the trig ratios above, these trig ratios, I'm going to work out sine 30, cos 30 and tan 30 and see what we get. So let's do that then. So sine of 30 degrees is equal to, well, that's the opposite, which is 1. Over the hypotenuse, which is 2, so sine 30 is equal to a half. Cos 30 is equal to adjacent. Well, the adjacent is root 3, and again the hypotenuse is 2. And tan 30 is equal to the opposite, which is 1, over the adjacent, which is root 3. So now we have exact values for sine 30, cos 30, and tan 30. Don't forget these are all degrees. Well, we're going to redraw the triangle again this time. But what we've got now is we've got 60 degrees. We can use this angle. And again, we've got exactly the same lengths, 2, 1, and root 3. But this time, my opposite and adjacents are going to change. So I'm going to relabel them like I did before. So the hypotenuse is going to be the same. But now my opposite is opposite the 60-degree angle, which is root 3 here. And then this means that this now becomes my adjacent. So we're going to run through exactly the same process. It's now sine of the angle, which is 60 degrees, is equal to, well, it's the opposite, which is root 3 over 2 over the hypotenuse. So cos of 60 is equal to, that's the adjacent, which is 1 over the hypotenuse, which is 2. And then we have tan 60, which is equal to, that's the opposite, which is root 3 over 1, which is exactly the same as just root 3. So we've done sine 30, cos 30, tan 30, and the same for the 60-degree angles. So how do we do this now for the 45-degree angles? Well, again, we need a different triangle this time. So I'm going to draw another triangle up on the right here. And the triangle I'm going to choose this time is I need to have an angle of 45 degrees and a right angle. So I'm going to choose this here is going to be 1 and 1. That now means I have an isosceles triangle, which means that this must be 45 degrees and this must be 45 degrees. Again, using Pythagoras, I should be able to work out the length of the hypotenuse in this case. And we know that 1 squared plus 1 squared is equal to, I'm just going to call it h again, h squared. That means we have 1 plus 1, which is 2, is equal to h squared. So this time h is equal to root 2. Okay, let's put that in. And I'm just going to redraw it again down the bottom here. And we're just going to run through exactly the same process as what we've done. So this time this is 45 degrees. We know that this is 1, we know this is 1, and we know that this is root 2. And we're going to label it again. So let's go for the hypotenuse. The 1 is opposite there, and the adjacent is on the bottom. As before, you can see all these 3 triangles here are labelled the same. Okay. Now, again, let's put it through. So we now have sine of 45 degrees is equal to, well, it's the opposite, which is 1, over the hypotenuse, which is root 2. We also have cos of 45, so cos of 45 degrees is equal to the adjacent, which is also 1 over root 2. And we have tan 45, which is equal to the opposite, which is 1 over the adjacent, which is 1, which is just 1. So that's how we get all of the trig ratios for sine, cos and tan of 30, 45 and 60 degrees. And these are also in your tables books, guys, so you don't have to learn them, but you should really know them after you've been working with trig for a bit. Hope that helped. Bye.